Alright guys, I'm going to try to work these problems out as best I can here so that you can get an idea of what's going on. A little bit different what we've done in class, but I want to at least give you some practice. So first, how much heat energy to raise a block of aluminum. So our formula is always Q equals MC delta T. The question is, what is the mass? Well, we're given a block of aluminum that's 25 centimeters by 10 centimeters by 3 centimeters. We're told that the density of aluminum is 2.70 grams per cubic centimeter. So now we have mass. The C value for aluminum I gave you is 0.9025 joules per gram. And again, degrees Celsius, degree Kelvin, doesn't matter. Kelvin, since this is in Celsius, times 255 degrees Celsius is the temperature change. That gives us 466,000 joules or 466 kilojoules. So here's how to do problem one. Of course, centimeters, 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 centimeters cubed, grams, and degrees Celsius, you're left with joules. Okay, number two, interesting problem. I like this problem. You're at a waterfall, and we're saying all the potential energy is converted to heat energy. The potential energy is mgh, and of course heat energy is mc delta T. Mass cancels. So we can say then that GH equals C delta T. We're solving for delta T, so delta T equals GH over C. G, we're told, is 9.80 meters per second squared. This is a great problem for keeping track of units, for those of you who don't like to do that very well. Height is 739.1 meters. The C, we know for water, is 4.184 joules per gram. Degrees Celsius. Now, I want to do something different here because I told you that joule equals, I can cross out joule, and it's kilogram times meter squared per second squared. Okay? And then we know that 1,000 grams is 1 kilogram. So look at our units. We get second squares cancel. We got meter times meter, cancel with meter squared. Grams cancels and kilograms cancel. And so whether you did Kelvin or Celsius is change in temperature, so 1.73 Kelvin or 1.73 degrees Celsius would be the energy change that the water would do in dropping from that height. Again, we're assuming no evaporative losses. Okay, I'm going to erase and jump on to problem 3. And you have all that already written down, so I'm not going to rewrite it. It's a little bit different than what we've done. That's why I gave it to you as a practice problem, because what you're looking for is the heat of combustion and not the heat of formation. Heat of formation is given to you. In fact, maybe I better write this down. Hydrogen. I won't put all the states of matter in. Try to save a little time here. To water, and that is negative 286.0 kilojoules. Carbon plus oxygen goes carbon dioxide. That's 393.5 kilojoules. And finally, 8 carbon plus 9 hydrogen. That's octane or isooctane, and that is negative 259.3 kilojoules. What's our reaction? Well, the reaction is the combustion of isooctane which is, I'll do a different color here, C8H18 plus oxygen yields CO2 plus water. Okay, that's our reaction. We got 8, so we put 8 here. We got 18, so we put a 9 here. We got 8 plus 4.5, so that equals 12.5 oxygen. All right, so this is our reaction. So obviously we need to reverse this. So we could say that C18 or C8H18 yields 8 carbon plus 9 hydrogen, and that changed it in this to 259.3 kilojoules. To get 9 up here, the 9 water, I've got to multiply this by 9. This becomes 4.5, and this becomes 9. So I've got to multiply this by 9, and I get negative 5,274 kilojoules. And then I've got to multiply this by 8. So multiply this by 8, and that gives me negative 3,148 kilojoules. I add all this together, I get negative 8,162.7 kilojoules, or to 3 significant digits, negative 8,160 kilojoules. Making sure that this all works out for us. I've got 8 carbon dioxide. Here's my reaction now. I've got 8 carbon on this side. I mean, this one I have to use, I'm sorry. This one I have to use versus up here. So I have, in terms of my hydrogen, I've got 9 hydrogen, cancels with 9 hydrogen. 8 carbon, cancel with 8 carbon. Now I just add the reaction together, and I get C8H18 plus 8 plus 4.5, 12.5 oxygen, yields 8 carbon dioxide plus 9 water, which is the reaction I had here. So therefore, that's my numeric answer. It's a little harder problem. Nothing different than what we've done before, just a little bit of a twist in that I gave you this and we solved for the combustion as opposed to giving you the combustion information and solving for that. It's the only difference in it. So I want to show you how you can do both types of problems here. Okay, so again, I'll erase the board, and I hope my video is working because I don't want to have to do all these again, but I will, necessary. Okay, number 4, you're making 450 grams of hot chocolate. So our big formula is Q lost equals Q gained. The hot chocolate loses heat, and we have 2 things happening here. First of all, the ice has to melt, and then the ice water will gain heat. So the mass of the hot chocolate is 450 grams. This is 4.184 joules per gram degrees Celsius times temperature. It's 95 degrees, that's what we're starting at, minus the final temperature. That's what we don't know. The mass of the ice is 50 grams. And this is a number I haven't given to you before, but it's on the worksheet. 334 joules per gram plus MC delta T. So we got the ice water now has to warm up, so 50 grams times 4.184 joules per gram degrees Celsius times TF minus TI. TI is 0, so that factors out. So doing the mathematics, these units cancel out, degrees Celsius and grams cancel out here. So we're left with 178,866 joules minus 1,883 joules per degree Celsius times TF equals 16,700 joules plus 209.2 joules per degree Celsius times TF. So we get 2,092.2 joules per degree Celsius times TF equals 162,166 joules. And all I did was bring this on this side of the equation, so it took 178,866 minus 16,7, and it took 209.2 plus 1,883 to get this value here. Okay, so I solved this, so I can say TF equals 162,166 joules divided by 2,092.2 joules degrees Celsius, so joules cancel, and our final answer ends up being 77.5 degrees Celsius. So if we place 50 grams of ice and 450 grams of hot chocolate, 95 degrees, the final temperature is 77.5 degrees. Okay, and finally problem 5, which you'll be happy to look at, is a much easier problem than what I've been doing on the board so far. Delta G equals delta H minus T delta S. Delta G is given to us as 176 kJs per mole. The temperature is 298.15 Kelvin, and S is given as 0.285 kilojoules per mole Kelvin. So do the math there, and you get 85.0 kilojoules per mole. Do the math again, you get 91.0 kilojoules per mole. Since this value is positive, it makes the reaction non-spontaneous. So I know I went through fast on this. You can obviously pause, go back, rewatch. This is how you would do those first 5 problems. Again, this is the practice one, and I'm going to give you a worksheet now, work on that, and hopefully it won't be quite as challenging as you may have found this. All right, hope you have a good day.